The last video, we constructed an experiment where we had a drug that we thought might help control people's blood sugar. We looked for something that we could measure as an indicator of whether blood sugar is being controlled, and hemoglobin A1C is actually what people measure in a blood test. We have a whole video on it on Khan Academy, but it is an average measure of your blood sugar over roughly a 3-month period. So that's the explanatory variable, whether or not you're taking the pill, and the response variable is, well, what does it do to your hemoglobin A1C? And we constructed a somewhat classic experiment where we had a control group and a treatment group, and we randomly assigned folks into either the control or the treatment group. And to ensure that one group or the other, or I guess both of them, don't end up with an imbalance of, in the case of the last video, an imbalance of men or women, we did what we call a block design, where we took our 100 people, and we just happened to have 60 women and 40 men. And we said, okay, well, let's split these 60 women randomly between the two groups, and let's split the 40 men between these two groups so that we have at least an even distribution with respect to sex. And so we would measure folks' A1Cs before they get the treatment or the placebo. Then we would wait 3 months of getting either the treatment or the placebo, and then we'll see if there's a statistically significant improvement. Now, this was a pretty good, and it's a bit of a classic experimental design. We would also do it so that the patients don't know which one they're getting, placebo or the actual treatment. So it's a blind experiment. And it would probably be good if even the nurses or the doctors who are administering the pills, who are giving the pills, also don't know which one they're giving. So it would be a double-blind experiment. But this doesn't mean that it's a perfect experiment. And there seldom is a perfect experiment. And that's why it should be able to be replicated. Other people should try to prove the same thing, maybe in different ways. But even the way that we designed it, there's still a possibility that there are some lurking variables in here. Maybe, we took care to make sure that our distribution of men and women was roughly even across both of these groups. But maybe through that random sampling, we got a disproportionate number of young people in the treatment group, and maybe young people responded better to taking a pill. Maybe that it changes their behaviors in other ways. Or maybe older people, when they take a pill, they decide to eat worse because they say, oh, this pill is going to solve all my problems. And so you could have these other lurking variables like age or where in the country they live or other types of things that just by the random process you might have things get uneven in one way or another. Now, one technique to help control for this a little bit, and I shouldn't use the word control too much. Another technique to help mitigate this is something called matched pairs design. Matched pairs design of an experiment. And it's essentially, instead of going through all of this trouble saying, oh boy, maybe we do block design or all this random sampling, instead you randomly put people first into either the control or the treatment group, and then we do another round, you measure, and then you do another round where you switch, where the people who are in the treatment go to the control and the people who are in the control go into the treatment. So we could even extend from what we have here. We can imagine a world where the first 3 months, we have the 50 people in this treatment group. We have another 50 people in this control group that are taking the placebo. We see what happens to the A1Cs. And then we switch, where this group over here, and they don't know, first of all, ideally it's a blind experiment, so they don't even know they were in the treatment groups, and hopefully the pills look identical. So now that same group for the next 3 months is now going to be the control group. And so they got the medicine for the first 3 months, and we saw what happens to their A1C, and now they're going to get the placebo. They're going to get the placebo for the second 3 months, and then we are going to see what happens to their A1C. And likewise, the other group is going to be switched around. The thing that the folks that used to be getting the placebo could now get the treatment. They are now going to get the treatment. And the value here is that because everyone is going through, is that for one period is in the control group and for one period is in the treatment group, and they don't know which one is happening, you are less likely to have a lurking variable like age or geographic region or behavior cause an imbalance or somehow skew the results or give you biased results. So this is an interesting thing. And even what I've talked about in this video and the last one, these are just different ways to approach it. And as you construct experiments, this is in medicine, you'll obviously construct experiments in other fields. It's important to think about what types of things are practical to do and also have the best chance at giving you real, I guess you could say, an unbiased and real information as to, in the case of an experiment, to the efficacy of something, or whether a certain variable, an explanatory variable, really does have a causal effect on a response variable.